I will now demonstrate the functionality of the neural network for fingerprint recognition. So I already have the neural network started training because it takes a little while to train, so figured shouldn't sit there on the camera for 4 or 5 minutes while it trains. So the first step in training the neural network is setting the input and the targets to be in the proper format. The input data has to be in the format of each image having all of its pixels in one row. So since there were 80 different input images, there were 80 different rows with 262,144 pixels each. These 262,144 pixels correspond to each of the pixels in the 512 by 512 image. This also corresponds to the number of input neurons in the input layer of the neural network. Then the input targets had to be in a similar format, but rather than corresponding to the inputs, they corresponded to the neurons in the output layer. We can see here that the neural network is training, and it shows that we have a neural network with 262,144 neurons in the input layer, a hidden layer with 254 neurons, a second hidden layer with 125 hidden neurons, and then a third layer with 10 output neurons, a third weighted layer with 10 neurons in the output. This here shows the number of epochs that have been performed in the training thus far. This shows the time that has been gone on for training, and down here you can see the number of validation checks that have passed. When either the epochs reach 1,000 or the validation checks reaches 6, the neural network stops training and it is said to be well trained. So we will wait for the neural network to be well trained before we can perform any of the matching algorithms. Never seen it take more than 18 iterations or 18 epochs, so we should be almost done. The number of epochs varies every single time because the data is trained different. The network is trained differently every time. The input data is randomly selected in its order, and this causes the weights to be updated in a random order after each epoch. And now you can see it reached 6 validation checks after 17 epochs, and hence validation was stopped. We will now perform one-to-one matching using the neural network. One-to-one matching on the neural network is slightly different than it has been on the other types of algorithms because it actually performs 10 one-to-one tests at once. Since each input to the neural network causes 10 output neurons to have different weights, each of the weights is analyzed in one-to-one matching, and if the weight is above 0.1, then it is said to be a match. So essentially, 10 different one-to-one matches are performed for each input case. We'll now perform some tests, and the neural network performs differently every single time it's trained, so it is unknown how the network will perform this time. Let's test it for, say, image 42 of 80, which means it would be a copy, the second copy of the 6th fingerprint in the database. There are 10 outputs. And you can see here, 1, 2, 3, 4, 5. The 6th one matched, the other 9 did not match, and it took approximately 0.244 seconds to perform 10 cases of one-to-one matching. You can try another, let's try 55. So this would be the 7th or the 8th. 6, 7, 8. It shows the 8th matches, but there was also another neuron in the output layer with its weight above 0.1. So we do have a mismatch here with the sixth, with matching it to the image for this sixth fingerprint. I'll now demonstrate one-to-all matching, which finds the best match, meaning the neuron in the output layer with the heaviest weight. Let's go with 27, meaning hopefully we'll get returned that it matched the fourth. 10. And there it shows it matched the fourth and took about 0.245 seconds. We can try another. Let's try one that'll maybe match the sixth, so that would be like 45. Let's try. And that one was wrong. It shows 8. So let's try possibly 55. That shows 6. 36. That's terrible. And if you try 40, you get the correct output with 5. Now, the performance of the neural network varies every single time, as I said, and it was shown in the results that the accuracy of one-to-all matching is approximately 58.75%, which was obtained from multiple trains and multiple cases of one-to-all matching being performed. And that concludes the demo of the neural network matching, which concludes all 4 types of matching that were performed in the project. It was seen once again that neural network matching was the fastest and the most accurate for one-to-one matching and one-to-all matching. It may not have seen in this demo that the one-to-all matching for neural networks was the most accurate, but that was because the test cases were random, and so it performed differently every single time. Thank you for watching the demo, and that's it.